Hello students, welcome to CMI's online classes, and this video is for class 6. The name of the topic is light, shadow and reflection. So in our previous video we talked about luminous and non-luminous objects. Then we talked about different source of light. We also talked about natural and artificial source of light. Then we talked about the materials, transparent, translucent and opaque material, and due to the translucent and opaque medium, shadow is formed. Okay, so in this chapter we will talk about a few properties of light and a general idea of reflection. Okay, so let's start the topic. So first of all, what we have in mind, what is light, what are its features? Okay, that means why we can see light. Okay, why we can see the objects in the day but not in the night. Okay, there must be something why we can see the image in the mirror, and some image can be opposite. That means what you can say is closer, or some words is inverted. Okay, so we will talk about these all things. So for that we have to talk about properties of light, then its objects, then reflection. Okay, we will talk about this much only in this topic. So first of all, let's talk about properties of light. So light have various properties. Number one and the most important is it travels in a straight line. That means it's not that it comes in a curved way. Okay, or when you are inside, it will come through the passage and through light on your body. No, it's not that. It always travel in a straight line. So this is the first and foremost or most important properties of light. So we have an experiment here. You also can do at your home. Okay, so here we have placed a basement. Okay, and on the one edge, you people or the persons can view, and at the extreme end we have lit a candle. Okay, so you can see the flame of that candle, and in between them we have placed three boards of same size. Okay, board A, board B and board C. Now the thing is that we have to make a hole in all the three boards, and that hole must be on a fixed or same way. Okay, it's not that you just make a hole at the middle of the board in A, and in board B you just make the hole at the extreme end, at the corner of the board. Okay, it's not that. You have to make a hole in a similar way. That means if you are making a hole at the middle, you have to make the hole at the middle only, so that we can see the flame. Okay, so if we place the three boards and if you observe from the hole, we can easily see the flame of the candle. Okay, but the thing is that in figure B, if any of the board is moved or misplaced, then what will happen? We can't see the flame. Okay, it's not that from C it will enter to B hole, then it will come to A, then you will see that flame. It's not that. If any of the board is misplaced or moved, the light is blocked. Okay, either you move B. In this figure we have moved B. Either you move A or either you move the board C. Okay, so this proves that light always travels in a straight line. Okay, you all also can do the experiment. It doesn't require any general instructions or uh, expensive materials or whatsoever. Okay, so this proves that light travels in a straight line. Now let's move to another properties. And another property is light travels much faster than sound. Okay, that means when light and sound is there, okay, we can see the light first, then the sound. Okay, for example, thunder and lightning, okay, they start at the same time. And when do they mostly occur? They usually occurs during the monsoons. Okay, so what will happen at that time? First we will see the light, okay, flash of light. After that we can hear the sound, but the sound is heard later after we see the light. So number one example is thunder and lightning, which proves that light travels faster than sound. Second, we have the pistol or the the gun whatsoever, okay, or revolver. When a starting pistol is fired, starting pistol means during the what you can say, sports event, okay, while running 100 meter or 200 meter or 50 meter. When a starting pistol is fired, we see the smoke first. That means light. Okay, smoke means light. Sometimes smoke also comes outside, but mostly we see light first. Then we hear the sound of a gunshot. That means bang. Okay, this also proves that light travels faster than sound. There are various other examples also. Okay, like when bulb is blown, okay, or tube light whatsoever, the light first of all comes, then we will hear the sound. Then let's move towards another topic. At what speed? We talk that light travels very fast, but at what speed? Okay, it travels faster than the sound, but there must be some speeds. Okay, so about 3 lakh kilometers per second or 1,86,000 miles per second. That means you can imagine if the moving car, it travels at around 100 kilometers per hour, and when you see it, fraction of seconds, we can't see the car. But imagine 3 lakhs kilometers per second, at what speed the light travels. Okay, so if this travels, we can calculate that it makes 8 rounds in 1 second when light is to travel around the earth. Okay, so it's quite fast, faster than sound. Then let's move towards more properties. So number one properties was light travels in a straight line and is in a form of energy, and we discussed about that also. Okay, we discussed using the cardboard and a candle. Okay, second, light travels much faster, that means 1,000,000 times faster than sound. We also have an example there of lightning and thunder. Then we have an example of a gunshot. Okay, third, we see things because they reflect light into our eyes. Yes, the third one is also very much important. As for example, wind. So for third property, we will discuss a few examples. Okay, as for example, we can see the object. Okay, in a daylight, we can see the bus, or we can see the car, or we can see each other. Okay, because the light reflected in that object enters at our eyes, and we can see that object. How we can prove that? The same thing when kept in a dark room. Can you see? Suppose there is a what you can say, a book, suppose. Okay, in a daylight you can see that book, but same book, when it is kept in a dark room, can you see? No, we can't see that book because light is not reflected on that book and that light doesn't enter our eyes. So this proves that we see the object when light is reflected on that object. That was the third one. The fourth one, shadows are found when light is blocked by an object. Okay, so that we discussed in our previous video. Okay, shadows are found. So when light is blocked, we can see the shadow, and the shadow can be of various sizes depending upon the source of light, where it is kept. Is it kept closer or it is far away from the object? Okay, means source of light. So this was discussed earlier, but also we can say that when light is blocked by an opaque material, okay, a shadow is found. Sometimes shadow is found when translucent material also blocks the light. That was the fourth one. Now fifth one, visible light is only a small part of the electromagnetic spectrum. Okay, that means this word electromagnetic spectrum, it's a quite standardized term. Okay, you will just learn this topic or the word in your higher classes, but I can explain you this. Okay, that means whatever the light we see, it's not the whole part, only a small part is visible, the other part are invisible to human eye. Okay, we can't see other lights, but other animals can see because they have a more complex or more magnified lenses in their eyes. Okay, so only small part of the light enters, or we can see only small part of the light. Okay, so these all are the properties of light. Now let's move towards, as we already discussed, that when light is reflected, then only we can see the object. So for that we have light can be reflected, bent or refracted depending upon where it falls. Okay, as for example, let's take example of water. Okay, when we put a light, what will happen? Some part of light is absorbed, some is transmitted and some is reflected. That means we can see the light. Okay, so we have an incident ray, reflected ray and the absorbed ray. Okay, we will talk about this in our further discussions. Okay, so let's say we see things because they reflect light into our eyes. That was the third properties. This is literally the only way we get to see things, otherwise we can't see the things. That's why it is said that in a dark room we can't see the things clearly. Okay, if it is completely dark, we can't even see a small things. Everything seems dark to us. So all objects we see either create light or reflect light. That means the sun, okay, the star, they create light. That's why we can see. And let's talk an example of moon. They reflect light of the sun. That's why we can see the moon. But there is a question, why we can't see other planets? Mars, Jupiter, Venus. Okay. Why? Because they are far away from us. Okay, our eyes can't see the object which are more far. Okay, but we can see stars because it has its own light, and moon, it reflects the light of the sun. Okay, and there are a few other things, that red light is more attracted. Okay, we can see the red light far away from. Okay, that's why in most of the vehicles, or we can say in the traffics, red light is mostly used. Okay, so let's move further and discuss about laws of reflection. What are laws of reflection? So we have incident ray. What do you mean by incident ray? The slides that we saw. Okay, incident rays are those rays which falls on the object. Okay, the light ray falling on any surface is called the incident ray. Means it is incidenting. Okay, the ray of light is incidenting. Then we have another term, that is reflected ray. What do you mean by reflected ray? Okay, the incident ray, when it falls on a surface, that means reflected ray. That means those ray of light when falls on this surface, and if it is reflected, that is called reflected ray. The light rays that comes back after reflection is called the reflected ray. Similarly, we have normal rays. Normal rays means the line perpendicular to the reflecting surface is called the normal ray. That means it is perpendicular. That can be mostly observed when light is at the top or overhead. Okay. Then we have angle of incidence. The angle of incidence between the incident ray and the normal ray is called the angle of incidence. That means a half portion. Then we have angle of reflection. The angle between the reflected rays and the normal rays is called the angle of reflection. That means we have taken normal ray as the base. Okay, that means where it is incidenting. Okay, we call it angle of incidence. And those which is reflected, the angle we take is called angle of reflection. Okay, let's see here. Okay, so here we have a figure also. So this ray is called angle of incident ray, and this is reflected ray, and this red one is the normal ray, and the angle between the red one and the incident ray is called angle of incidence, and the angle between the normal ray, that is the red one, and the reflected ray is called the angle of reflection. Okay, so this was the figure. Then we have regular and diffused reflection. What do you mean by regular and diffused? So regular reflection is when light is scattered in same direction. Okay, that means this red portion is the incident ray. Okay, and when it is scattered in the same direction, it is called regular reflection. And this type of reflection only occurs when the surface is smooth. Okay, when the surface is smooth. But if the surface is uneven, or rough, or dull, what will happen? They will form a diffused reflection. Okay, so diffused reflection is when light is scattered in different directions. Okay, that means it's not in the same direction, and that occurs because the surface is rough or dull. Okay, we can see here in the above figure, in regular reflection, we can see that it is reflecting in a same direction. Okay, whereas below that, the incident ray and the reflected ray is not same. Okay.